At present, the number of electrical energy consumers is growing, and they are constantly loading electrical network with reactive component of power consumption. Reactive current circulation between the generator and the consumers is converted into thermal energy in power distribution system, thus creating additional load on generator, transformers, cables, and distribution device, contributing to power losses and voltage drops. The application of special reactive power compensation devices can improve the reliability of power network and increase power system capacity. The effectiveness of these devices largely depends on the training of personnel who will maintain them. The development of laboratory bench designed for the investigation of the impact of reactive power compensation in current consumers on voltage and energy losses in power transmission lines, and its integration into the training simulator of dispatch control system is considered in this paper. The most effective way concerning reactive transmission parameters compensation at industrial enterprises is the use of capacitor units. In order to improve the quality of education and introduce modern information technologies into the educational process, the training laboratory branch for investigation and reactive power compensation in low voltage electrical network was developed at the Department of Electrical Engineering of Ternopil Ivan Pulul National Technical University. The basic element of the developed training laboratory bench is the reactive power control. PFC-6RS, which is designed to regulate the power factor in 50 Hz low voltage network with the ability to control reactive power compensation units with 6 contactor outputs. The proposed scheme for connection the reactive power compensation controller to the load, which will be used during laboratory work, is shown in figure. The main unit of the developed laboratory bench consists of the metal power cabinet with 5 capacitor banks of different rating, 5 magnetic contactors, 5 three-phase fuse, and a circuit breaker. PFC reactive power controller has data transfer interface according to Modbus R2 protocol, as well as configurable discrete inputs and outputs. The display shows the installation status and main parameters. Therefore, the decision to integrate the developed laboratory bench into the training SCADA system energy of the software and hardware complex Trela was made. This system is the simulator of the automated dispatch control system for investigation and controlling the electrical power system modes. In order for the hardware and software complex to be able to exchange data with PFC-6RS reactive power controller, it is necessary to write the exchange program based on Modbus R2 protocol. The developed program file and device Modbus R2 card and PFC-6RS reactive power compensation controller itself a real model of energy training SCADA system. In order to integrate this model into SCADA system environment, graphical model and configuration file containing the following data are created. The program communicates with the equipment via communication channel, which is RS-232, RS-485 communication channel connection. Then the data are transferred to the equipment model where messages are proceeded. From the equipment model, the data are transferred to the real model, where the final processing is carried out. In order to carry out a real demonstration experiment in laboratory condition, the connection scheme shown in figure is the best one. Graphical model of the laboratory branch for the investigation of reactive power compensation with connected load is shown in figure. It is obvious from figure that after the load connection, the system selects the necessary combination of capacitor to provide reactive power compensation. In this case, the first, the second, and the fourth capacitors are connected. For convenience, the key by which these capacitors are connected are close and are presented in green color. According to the well-known formula, we can calculate that cosinus phi is equal 0.81. On the instrumental panel, the power factor is also equal to 0.81. The same value is shown on the control panel display of the reactive power compensation laboratory bench. This confirms the verification of power factor obtained by means of reactive power compensation laboratory bench and the proposed software package. Also, it can be seen from figure that the first, second, and fourth indicator glow, indicating which capacitors are connected at that moment. The application of reactive power compensation means make it possible to reduce significantly the electricity losses during its transportation by reducing power transmission line heating. The use of special reactive power compensation devices has a number of advantages. The main ones among them are improvement of power supply quality, increase of the equipment service life, saving in cost for power supply network arrangement, absence of fines, energy consumption saving. Thank you.